Hello there, my name is Mike Yeager. I am the Director of Applied Technology for vScenario, and this presentation is just a general overview of what vScenario does and how we do it. So let's jump right into it. Just a couple of quick things about vScenario as an organization. One of the things that makes us special and differentiates us from a lot of other organizations is our makeup and the people that we have in our company. And really those people can be divided into three different groups. Subject matter experts, technologists, and builders. So subject matter experts, we have elite ex-special forces military. We have construction experts with super skills in different areas. We have technologists like myself who understand software development and technology and the latest and greatest in hardware and software. Then we also have builders, construction professionals who know how to build, master builders who have built some of the most complicated structures you can build, hotels, casinos, hospitals, data centers, substations. And so that group of people allows us to really effectively add value to our clients, which are in general power and utility companies. We can bring a lot of technology solutions, but if you just have a bunch of nerds who know how to code and know technology but don't really understand how things go together in the field, who have never put on a hard hat and steel-toe boots and walked a site, it can be there can be a good bit of detachment between solutions that are developed and what actually is really needed. And so having this mix of people really helps us actually solve real problems leveraging technology. So that's a big part of who we are as a company. And what this presentation is going to focus on in a sentence is leveraging 3D modeling and reality capture techniques to generate efficiencies holistically within a utility. And so reality capture is the process of real-time data acquisition about a site and creating a 3D model of the existing conditions of a site using that 3D data. So we're going to talk more about that, but really we want to talk specifically about how that actually generates efficiencies within a utility. And we're going to talk about 4 different areas that those efficiencies can be realized in the design and construction world, in operations and maintenance, physical security, and safety and training. So really the important question is, okay, that all sounds really nice, but so what? Who cares? Well, the reason that's important and the reason that this matters and should matter very, very much to utilities is, for all the pizzazz and all the sexiness and all the, fancy technology, at the end of the day, this saves money, it saves time, and it allows people to work safer. So that's why this stuff matters, because it actually drives real, tangible value to the utilities by allowing them to lower costs, allowing them to accelerate project timelines, and to keep people safe in the field. And so that's why this stuff is important. And so everything that we say and do needs to be understood and digested in context of these 3 things, that what we're talking about saves money, saves time, and allows people to work safer. All right, so as mentioned, everything starts with acquiring data, going to a site, physically using different tools to gather this data about the site that we can use to produce an existing conditions type 3D model, a 3D as-built, if you will. And so that data sort of goes through a bit of a journey, and I want to talk you through that journey. It starts, as mentioned, with acquiring the data, physically going to the site, using different sensing methodologies to acquire that data. But then we have to take data by itself is just a bunch of numbers. It doesn't mean anything. So we have to clean that data up, merge all that data together, actually build this 3D model, and that's the data fusion process. But even that is really on its own pretty worthless. It doesn't, just because you have a 3D model doesn't necessarily mean anything. And so this third step is by far the most important, and that is the data application stage. So how do we take this 3D model and actually use it to solve real challenges? So this is where all the special sauce is. If we can't do that, just having a 3D model, it looks cool. People are going to ooh and ah because it's really neat, but it doesn't mean anything. And then lastly, the data storage component. These data sets are very big, they're very burdensome. And so as we begin to 3D model substations at scale, where does all that data live? Where is it stored? How do we secure it? So that's also a very important consideration. So we'll march through each of these step by step very, very quickly. So the data acquisition step. So when we go to a site, we use a few different data acquisition techniques to gather site data. We will fly a drone over a substation, a UAV, an unmanned aerial vehicle. We will also use something called terrestrial laser scanning and ground penetrating radar, which I will talk about here very briefly. So the UAV, when we fly a UAV over a site, we are acquiring a set of high-resolution overlapping photographs. So no video, nothing like that. It's just photographs. And so this image you're seeing in this video that I'm about to play, every single one of these green dots is where a drone has flown over a substation and has taken one single high-resolution photograph. And you can see a little bit of the projection of that photograph here in this image. If I play this video, then you can see all of these photos. And so the reason that this is a very effective data acquisition technique is because it is very, very fast, it's non-invasive, and very, very cheap. So all of this data for this substation was probably acquired in about 45 minutes. And what we can do with this data is just from these photographs, all these 2D photographs that you see, we can use a technique that's called structure from motion, which is an image processing technique that's not worth going into all of the nerdy details, but we can basically employ this image processing technique to produce 3D geometry, which you see below, from just 2D photographs. And so this model of a substation that you're seeing here below is just produced from these 2D photographs from a drone. So we can fly the drone over a substation. Takes about 45 minutes to gather the photographs that we need, and then very, very quickly, generally in most cases overnight, we can produce this 3D model of the substation using nothing but those photographs. And so flying the drone is a great start technique. It's not perfectly robust. It can't do everything, but it's a great start. And we use different techniques because each of them have their own strengths and weaknesses. The drone is really, really great at characterizing the topology and the terrain. So all of the actual ground and the hills and the valleys and all of the actual nooks and crannies of the topology. It does not do as well at spatially characterizing all of the little gizmos and gadgets within the substation. We use a different technique for that. But for creating a perfect 3D digital replica of the terrain, the drone does a very, very good job. And so that's step 0. And then step 1 is getting in there and actually laser scanning. A laser scanner is a range finding device that sits on a tripod and basically sends a laser beam out. That laser beam hits something and flies back. And based on the time of flight of that laser beam, the unit knows exactly how far away the object was that it collided with. And so this happens using a spinning mirror that happens very, very fast, and sends out millions and millions and millions of these laser pulses to create what's called a point cloud. And that's what we also looked at in the UAV model. A point cloud is exactly what it sounds like. It's a big cloud of points. Every single one of those points has an X, Y, Z value, a position coordinate, and it also has a color associated with it, an RGB. And so the UAV and the terrestrial laser scanner are just two different ways of generating a point cloud, but they have strengths and weaknesses in different areas. So if we look at the terrestrial laser scanning, all of these circles that you see before I play this video are where the laser scanning unit was set on the tripod. And this video kind of shows you just how all of those laser scans are brought together into one single 3D model. Here in a second you'll see a little bit more clear kind of fly-through of the point cloud. So this gives you a sense of just how dense and robust and complete this 3D model is. And so the laser scanner is very, very good at getting all of the little gizmos and gadgets of the substation, but because it's a ground-based technique, it actually sits on the ground. It is not as good at capturing all of the terrain. You can see also we use the laser scanner inside the control rooms to get every control box, every switch, panel, piece of conduit, all of that gets baked into the 3D model. So that is flying the drone and using the terrestrial laser scanner. Now that gives us a perfect 3D representation of everything above ground, but we also want to see everything below ground. And for that we use ground penetrating radar. Now ground penetrating radar is just like an ultrasound on a pregnant woman. It just sends waves into the ground, and based on the reflections of those waves can give us a sense of what's going on below ground. Now, one thing that's important to understand is it's not X-ray vision. We can't see perfectly clearly into the ground and get a sense of everything going on. It's a little bit more, it's not a perfect science. And so the way that we do this is we use ground penetrating radar as a sort of a confirm deny technique with the as-built. So we will procure the underground utility as-built from the utility for a particular site, and then use ground penetrating radar to confirm or deny the accuracy of those as-built. And so if we let me fast forward this video forward just a little bit. So you'll see this is a 3D model of a site in which we have procured the as-built. We have used ground penetrating radar to confirm what's on the as-built and the depth of all of those items, and then we manually model all of those items in. And so now within our 3D model of the point cloud from the UAV and the point cloud from the terrestrial laser scanner, we have this model of all of the underground utilities brought into the exact perfect spot at the exact perfect depth that they exist in real life. So now we have acquired all the data that we need to produce an exact digital replica of a site, both above ground and below ground. But all of these data sets have to be brought into one single space. Right now they exist kind of on their own in different spaces, and so we have to bring them together. And we do that by mapping them all to what's called the World Coordinate System, using traditionally surveyed ground control points. And so what that means is that we use traditional surveying, and we use aerial targets that appear in both the UAV model and the terrestrial laser scanning model to merge all of these data sets into the World Coordinate System. So what that means is that this model, this point cloud model that has hundreds of millions of points, each one of those points now has a perfectly accurate northing, easting, and elevation associated with it. And so this is what gives us a very useful, highly coordinated 3D model that we can start to use for all kinds of stuff. This little demo reel here just kind of shows you, helps you get a sense of just how robust and how complete these 3D models are and can be. So we see every nook and cranny of the substation, every suspended line, the terrain, everything gets modeled in. And so we can get a sense of just how complete and how precise these models can be. And here in a second we'll talk about just how we can actually use them and apply them to solve real challenges. And so, when we talk about applying these models, we want to, as mentioned at the beginning of the presentation, focus on these 4 different areas: on design and construction, on operations and maintenance, physical security, and safety and training. So if we talk first about design and construction, everything that we've talked about up to this point is what is called reality capture, capturing the exact geometry of a site as it exists right now today. But what if the site needs to change? Or what if we want to build a site completely from scratch? Or what if we want to make some kind of facility enhancement, maybe a perimeter security upgrade, or a new breaker bay, or an expanded control house, whatever the case may be? Well, then what we do is we employ what we call VDC, Virtual Design and Construction. And that means instead of just drawing all of these new site upgrades in 2D using traditional CAD software, we actually do it in 3D. We actually build 3D models of what is going to be constructed and virtually constructed. And so one of the, if any of you have a building background, this is a process known traditionally as BIM, Building Information Modeling. The reason that this is so valuable, so important, and so powerful is because while we're virtually constructing whatever it is that we're building, in this case the picture that I'm showing is a perimeter security system that has, you can see the physical barrier, you can see this tech post and these cameras. So this is all being virtually constructed, being designed in 3D. And what we can do is we can actually embed data into each of these elements. And so this camera, for example, we can embed all kinds of cost data. We can embed material cost data, installation cost data, operational cost data, how much this camera is going to cost us to operate in manpower, and then also the maintenance cost. So this gives you a true understanding of life cycle cost of whatever it is that you're going to construct. And all of that data gets embedded into these virtual elements as we are constructing. One of the other things that this allows us to do that is really a huge revolutionary idea and is really shifting paradigms in the utility space is conducting what are called virtual design reviews. So traditionally, any kind of new construction project, as it is being engineered, as it is being designed, the traditional process is at some given stage in the design phase, maybe 30%, 50%, whatever, everybody sits down around a big table. They all have black and white 11 by 17 printouts of the new design. It's all schematics, and everybody has a highlighter and a red pen, and just kind of march through the plan set one by one and try to solve any challenges and answer any questions. And this is not a very good process for anybody that does not have a very, very exhaustive engineering or construction background. If it's a project executive or a project manager or a security expert, they haven't spent their career reading plans, and so a lot of questions can go unasked. A lot of issues and challenges can be unresolved because of this gap between just staring at these flat 2D drawings that are all in black and white. So we can use this 3D model to conduct virtual design reviews. And so this is an example of a perimeter security upgrade project that we were a part of. So on the left-hand side of your screen, you see the point cloud model, the as-built that was conducted before construction or before design began. And on the right, you can see the virtually constructed perimeter security system. And so this has everything. This has the physical barrier, the concrete footings, the gate operator, all the conduit, access control, security cameras, intrusion detection, everything in the world that would go into this perimeter security system. And all of that is virtually constructed. So this is just a 3D model on the right that has been brought into the existing conditions, so we can see exactly what kind of challenges we're going to run into, whether there's going to be some guy wires that may give us some clearance issues, et cetera, et cetera. And so what we do is when we're at 30% or 50% or 60% or at some given design milestone, we can actually hop on just a Skype call, any kind of screen sharing, and we can virtually walk through the design and with the entire project team, with the engineers, with the security folks, with the operations and maintenance folks if required, any project stakeholder, and we can virtually walk through the design and solve any challenges in real time. And so this has been a total game changer with our clients, allowing them to, this has sped up the design process tremendously. It has saved a ton of money. And what we can do is we can model in so you can see this yellow sign up here that this avatar is walking to. That is a design issue that needs to be solved. And so instead of just looking at it in 2D on some engineering drawings, we can look at it in 3D, fly around the site, look at any angle we want to, and solve this challenge in a really near real-time way that is much more efficient. So virtual design reviews are a total game changer. Next thing that in the design and construction world that this allows us to do is a very, very powerful thing called 5D modeling. And so, we talk about 3D modeling. I think we understand that part of it, but we can add a few different dimensions, if you will, to our model. And that would be cost as the fourth dimension and schedule as the fifth dimension. And so if we have a 3D model, what we can do is, as mentioned previously, we have already embedded cost into this 3D model, and now what we can do is we can actually marry that model to a construction schedule, a sequenced set of construction activities, and produce what is called a 5D model. And that's what you're seeing here. And so you see the 3D model up at the top, and on the bottom, this very, very important plot, you can see this red curve through time, and that is your cash, that is your burn rate through time. And that is a very, very, very important quantity that gives the utility a sense of how much money they're going to need to be spending as this project progresses. And you can see, for example, here late in June on this particular project, there's a really, really big cash spike. And so, who knows what that is? It could be any piece of expensive equipment or whatever the case may be. But it gives the utility a very real sense of when there's going to be these big cash spikes throughout the life of the construction project. And so, and you have to understand, this is all done. This is all a design exercise. This is all done before any material has been procured, before any excavator has broken ground on anything. And so this is a very, very efficient way to front load the design and streamline construction and save a ton of money and build in a bunch of efficiencies. Lastly, worth noting in design and construction, I know this can sound like a massive paradigm shift, like we're totally flipping the engineering and design process on its head and totally, is this going to be just a impossible thing to sell to the utilities because it's just all new? What you need to understand is that at the end of the day, we still produce a 2D set of design documents, bridging documents, construction documents, whatever we want to call them. We just use the 3D model to get there. And so any change that's made in the 3D model automatically propagates to the 2D drawing set. And so at the end of the day, we're still producing a set of drawings, but this drawing set is much more comprehensive, much more robust than traditional drawing sets because we've used the 3D model to produce this, and because we have a construction schedule synced up to this model, because we have cost data embedded into the model, this drawing set is not just a schematic drawing of the design intent of whatever the project may be. It also has a complete schedule of values at the end of it. So every bracket, every nut, every bolt, every cubic yard of concrete, every cubic yard of earthwork that needs to either come in or get exported out, and every single cost associated with that. And so it also has the schedule synced up as well. So what this allows the utility to do is completely change the way that they issue RFPs. So instead of the status quo, which is issuing this very, very crude drawing set of what we want to build and having the contractor bid against it, this removes a lot of risk from the design package, because when everybody knows when a contractor is faced with risk, the only thing that they can do to mitigate their risk is to add money to their bid. So anytime there's any kind of uncertainty, when they don't understand something, they just add money, which costs the utility more. But when we can issue an incredibly complex, robust, comprehensive design drawing that has a complete bill of materials at the end, has cost data associated with it, has a schedule, you're basically telling the contractor, Mr. Contractor, here's what we want you to build, here's how much we think it's going to cost, and here's how long we think it's going to take. And that allows the contractor to bid much more competitively because a lot of his risk is now gone. So that is the benefits in design and construction. The rest of these are going to be much shorter, so don't worry. But design and construction, there's just a ton of application, and it's really where we really shine, vScenario, as an organization. So I wanted to spend a good bit of time there. Now, one of the powerful things when we talk about operations and maintenance is, the utility has, let's just say for the sake of argument, they have spent money to go out, fly the drone, laser scan, produce this 3D model. And let's say they've even used the 3D model for some kind of construction project. Maybe it was an expansion to an already existing site. We used the 3D model, we designed in 3D, produced our drawing set, put it out to bid, got the project done, completed, awesome. And so it's done. Well, traditionally what happens is then this 3D design model just dies. It just goes into a black hole, into a vault, and nobody ever sees or hears from it again. But you need to understand that this is an incredibly powerful tool ongoing as a facility maintenance tool. So imagine if your operations and maintenance folks had an exact 3D replica of a site that they could use as a planning tool before they execute any kind of maintenance activity. And so instead of the state of the art now, which is 4 or 5 people climbing into a truck, driving all the way out to a site. Maybe the site is in a really remote area, and then doing a site walk down to plan whatever maintenance activity they're going to plan, taking measurements, in a very dangerous situation. Substations are inherently dangerous places. They can instead use the 3D model, sit in the safety of a conference room at their headquarters, take any measurement they want to, plan out the entire maintenance activity without ever having to set foot on site. That is an incredibly powerful, saves a ton of money, allows people to work way safer by minimizing site walks, minimizing time on site. So from an operations and maintenance perspective, using these 3D models in perpetuity is incredibly valuable. Next, from a physical security perspective, similarly, being able to use a 3D model as a tabletop, if you ask any physical security professional, they will speak very highly of the use of a tabletop, being able to visualize different tactics and paths that a potential aggressor may take, how security policies affect sites in different areas. Maybe you have sites in very urbanized areas and sites in very rural areas. And so using these 3D models as a tabletop is incredibly powerful. And then lastly, in safety and training. And so I'm going to play a quick video that will talk you through how this can be used in a very, very powerful way for safety and training. And then we'll be right back with you.
One of the most powerful applications for 3D models of power and utility sites is for safety and training purposes. Virtual reality training inside site-specific digital replicas is the most effective way to train, because the best way to learn anything is by complete immersion. Imagine using a specific model to run different emergency response scenarios. A training subject can be tasked with an issue, placed in the training environment, and scored based on how quickly they can resolve the issue while following the correct protocols. The model can also be used for hazard identification training. Imagine placing new hires inside a model and asking them to safely navigate a site and identify pre-modeled hazards on a site. This creates unprecedented situational awareness by allowing personnel to see real hazards within real sites. The 3D environment can also be used for contractor or vendor onboarding. Imagine being able to put contractors in a model of a site they are going to begin work on in the future. This would allow them to get acquainted with the site, its hazards and logistical challenges from the safety of a computer without setting foot on site. For these reasons and many more, leveraging virtual reality and 3D models is revolutionizing safety and training for power and utility organizations.
Okay, and then lastly, after we have acquired the data, we have cleaned the data, fused the data into one seamless model. We have applied the data. We've used it for some kind of design and construction activity. We have given it to our operations and maintenance folks to use it ongoing throughout the life of the utility. Lastly, and very importantly, is where do we put this data? All this data is very, very big. It takes up a lot of space. It will max out servers and hard drives and blah, blah, blah very, very quickly. So where do we put it? What do we do? Well, vScenario has developed a proprietary software application that we call SiteSpy, also known as vCapture. And this application is a web-based viewing portal for 2D and 3D site data. And so without You don't need, an engineering background. You don't need a supercomputer. You don't need any kind of very expensive, very specialized software tools to view this data. This software platform allows anybody to get access to this data. Traditionally, these 3D models, these point clouds, are only usable by the engineering team because they have the supercomputers, they have the software tools, they have the background and the expertise. But that is greatly, greatly, greatly limiting the efficacy of this data that the utility has already paid for. So by employing this software platform that we call vCapture or SiteSpy, it allows anybody and everybody within the utility to gain access to this data and to use it. And so I'm going to play a quick video outlining the features of SiteSpy. So please check this video out.
SiteSpy is a web-based software application for managing critical asset site data. From aerial photography to point clouds to as-built drawings to site documentation, SiteSpy centralizes site information in a user-friendly interface. Imagine if executives, engineers, O&M personnel, or security professionals could access important site data when they need it. All sites are organized in a user dashboard according to user preferences for easy navigation. When a site is selected, the user can explore 2D and 3D datasets along with centralized site documentation. Engineering drawings can be digitized and overlaid on aerial photography, making rolled-up paper as-built a thing of the past. Ortho-rectified aerial photography from a drone is a useful tool for logistics planning and up-to-date site imagery. Because the image is ortho-rectified, it can be measured for quick takeoffs and planning, and notes can be added to share with colleagues. Traditional site documents can also be uploaded to a file sharing section to further centralize important site data. From engineering working files to site-specific safety information, accessing site documents can be made more efficient. SiteSpy can also be integrated with other legacy document management systems to avoid costly and time-intensive migrations. SiteSpy can also serve as a robust asset management tool for storing and disseminating asset information for O&M personnel. Imagine if component documentation could be found easily and quickly from a computer or mobile device before or during a maintenance operation. Additional site data like 360-degree photography acquired during terrestrial laser scanning can also be visualized within the platform as a coordination and visualization tool. Lastly, SiteSpy allows all users to interact with 3D datasets without complex software, hardware, or engineering prowess. From executives to engineers to operations and security personnel, SiteSpy provides a mechanism for getting the most life and value out of data that has already been paid for. By maximizing the efficacy of acquired site data, SiteSpy is revolutionizing the way that critical assets are managed.
All right, and then as far as the security of this data goes, without going into a huge tangent about the security, we leverage a service called GovCloud by AWS, by Amazon Web Services, to store all of this data. GovCloud is a dedicated US-only secure environment from Amazon Web Services. You have to actually apply, be vetted to even use this platform, and it is as secure as civilian data can get. So this is what is called UCI, unclassified controlled information. So it's not classified information, but it is sensitive and in the best interest of the United States national security. We want to control it. And so we use GovCloud, which is GovCloud meets all DoD security regulation guidelines for not only UCI data, but also for classified data and top secret data for the State Department. It meets HIPAA compliance, and HIPAA data is has as stringent requirements as unclassified civilian data can possibly get. And so this data is infinitely secure using AWS GovCloud. So we are happy to have that conversation with IT folks at utilities to alleviate their concerns about security of this data, because it is a very important consideration. And then lastly, just kind of talking through some utilities that are, I know a lot of this sounds like it's brand new and it's maybe totally revolutionary, and is it going to be really hard to get utilities to jump into doing this? And the short answer is no. There are a lot of utilities that are actively doing this kind of work and modeling in 3D. We've done work with a bunch of utilities, just to name a few: Hawaiian Electric, ComEd, AEP, Entergy, and all these utilities are understanding the value of 3D data and why they need to work it into to their workflows as a big efficient utility. And so just know, as you are talking to utilities about this, that this is not a new thing. What you will find is that there are a lot of utilities out there. All four of these are perfect examples of utilities that understand the value of 3D data, actively are trying to get into acquiring and using 3D data, but don't have the expertise or the background to do it. And that's why vScenario is a perfect partner. We want to position ourselves as trusted advisors for utilities to help them hold their hand through this transition between 2D and 3D, and really just partner with them to help make them better. Well, thank you very much for your time. Hope you have enjoyed the presentation, and we greatly look forward to working with you all.